Alright student, let us start today's topic which is permutation combination. We did part 1 of this particular topic yesterday, and now today we are going to finish this particular chapter. So alright, let's start with the first question of the day. Okay, the first question says that how many 4-letter words can be formed using the letters of the word ineffective. So we are given, this is a very common problem, and the reason that I have taken is it is a beautiful problem to understand the concept when objects are getting repeated. So for example, if I write the word ineffective, right? So first of all, the target here is to figure out how many words are getting repeated, and they are okay. So now let us take it in this way, that 2 i's are there, 3 e's are there, 2f, and these 4 elements are not getting repeated, so they are only once. If I say this is a 11-letter word, right? 11-letter word. So if I have asked you what is the total permutation of this particular word using 11 letters only, then the answer would have been 11 factorial divided by 2 factorial for I, 3 factorial for E, and 2 factorial for F, right? This is the total permutation. Total permutation, right? Total number of 11 letter words, right? This is the answer for 11 letter words. But we are being asked how many words? We are being asked 4-letter word. That is the problem now we have. So for 4-letter word, now we have multiple options, right? Let's see how many cases I can tell you. So case 1 could be that you pick all 4 distinct, no repetition in the digits or the letters, all 4 distinct letters. This could be a one case. Okay, let's take case 2 then. It could be 2 distinct, right, and 2 same. What could be the case 3? Tell me very quickly. Yes, it could be 2 same, 2 same, 2 of one kind and 2 of the other kind, because we have that kind of option available with us, right? So this is what you people will say. But believe me, there is another case 4 here. So what will be the case 4? 1 distinct, 3 same. This is also possible because we have 3 e's here. See here. So 1 distinct, 3 same. So this is the total possibility that I can say that this particular word will have if you start choosing 4 letters, right? In fact, if I talk about this, case 4 should come after the case 1 itself only. Okay, so now let us see what we can do about this particular question. So I will again split this into 2 components. One is the selection component, and then the other would be the arrange part, right? Arrangement. As I have taught you in the class 1, that first of all the job should be to select, and then you people should arrange. So let's say if all the 4 are distinct, how many distinct letters are there? Can you tell me? There are total 11 words in the dictionary, in this particular word. How many distinct letters are there? So these are 4, right? Okay, I, E and F. If I take them individually, so they are distinct. So if I say I, E, F, N, C, T, V, so there are 7 different or distinct words. Out of that, you people have to choose only 4. So 7C4, right? This is very crucial. So there are 7 distinct letters, out of which 2 of them are repeated, 3 of one kind and 2 of one kind. Got it? And how do you can arrange 4 distinct letters? Obviously 4 factorial, right? So answer would be to multiply these two. So this is the answer for case 1. So if I have to write the complete answer, that would be 7C4 into 4 factorial. This is how you will write the answer for this one. Now let's talk about the case 4 first of all, right? So it says 1 distinct, 3 same. So if I talk about 3 same, what is the option that you people have? There is only one option of 3 same, that is 3 e's. So I would say only 1C1. So 1C1 is nothing but for this particular component, 3 same. I will not write 3C3, because if you write 3C3, though the answer will still be 1, but for if I write 3C3, like something like this, this means you have selected from 3 items from a pool of 3 items. Now our pool is to select triplets, right? 3 same. This means triplets. You have to select triplets over here. So count how many triplets are there. There is only 1 triplet available to you. So that is 1. So out of that you have to select 1, right? Now E is already gone with you. Now E is gone, right? Now you want 1 distinct, so that could be NCTV. Okay, so people generally do a mistake over there, that they generally write 4C1 here. But believe me, you can also have I, you can also have F. So the distinct letters now available here in the pool are I, F, N, C, T and V, right? So there are 6 options available, and out of this you still have to select one, right? So this is how you people will select in this. If I talk about the arrangement part, how do you people can arrange when 4 letters are there? So 4 letters means 4 factorial, but out of which 3 are repeated, so you will divide by 4 factorial by 3 factorial. So this answer becomes 1c1 6c1 into 4 factorial by 3 factorial. This is the answer we are looking for, right? Let's talk about two distinct, two same. So let's talk about two same first. So how many options are there of pairs? So two same means you can say that these are pairs. How many pair options are there? There are 2 i's. If I say there are 3 e's, you can also say there are 2 e's also. Obviously, 3 है तो 2 तो होंगे ही, right? So that means do you have 3 options of the pairs? 2 i's, 2 e's, 2 f's, out of which you want 2 same, that is 1. So I can say 3c1 because you want out of, I'm writing it here, there are 2i, 2e and there are 2f. Out of this particular bag you want only 1, right? Then what I will say for 2 distinct. So for example, you have picked up you have picked up 2i. So how many distinct letters are still left with you? One is for NCTV, right? And then E or F is also in the pair, right? So you again have 6 distinct letters, out of which now you have to choose 2 because you want 2 distinct. So, and if I talk about arrangement, 4 letters can be arranged in 4 factorial, out of which 2 are same. This is the answer. So for if I combine the complete answer for this will be 3c1 into 6c2 into 4 factorial by 2 factorial, right? Let's solve the last case. We have solved these 3 cases. Case 3 says 2 same, 2 same. So that means there is a pair, something where 2 pair कैसा है, 2i 2f वाला टाइप का पेयर, राइट? सो आपके पास देखो क्या है, 3 टोटल ऑप्शन थी अब की बार बैग में, उसमें से कितने पेयर्स चूज करने हैं? 2 सेम मतलब 2 पेयर्स सिलेक्ट करने हैं. दैट मीन्स यू विल नाउ हैव टू सिलेक्ट 3c2, right? And if I talk about arrangements, so then arrangement will be written this time 4 factorial divided by 2 factorial divided by 2 factorial. So the net answer here will become 3c2 into 4 factorial divided by 2 factorial 2 factorial. So this is, if you add them up, then you will get your final answer. So this is the way of solving the word ineffective. Very, very common problem, right? Go through the video once again if you are not clear with how I have solved. These are the 4 cases and you should remember this problem. Very, very crucial. Okay, now the next problem says find the number of ways in which a mixed double game can be arranged, right? So now what do you mean by a mixed double? Before going this is again a very standard problem. So mixed problem, right? Mixed problem, or we can say mixed double problem, right? So mixed double means that a team has 2 players, right? Configuration क्या है? There would be 1 man plus there will be 1 woman, right? Mind the spelling error here. Okay, so this is how this is being played. So if people who have watched tennis, they will immediately get the question, right? So you want a problem in which there is team A. Let me just write it here. There will be team A versus team B, right? There will be versus team B. It composes of 1 man, 1 woman here. It composes of 1 man and 1 woman here, right? So this is how a mixed double match is being played, right? And there are 9 married couples, so that means there are 9 men and there are 9 women, right? This is also given to you. If it is now given that if no husband and wife play in the same game, so that means when you are playing this particular sort of thing, then this man and wife should not be in team B, right? So how many such kind of games can be arranged? So if you see for a particular match, so this is the configuration of a match. Let's say if this is the match, right? For a match, 2 men and 2 women are required. 2 men, 2 women are required. This is the requirement of a match. So let's start with picking men, right? So out of 9 men, I select 2 men. That could be done by 9c2 ways, right? Now going to the part of, let me just write, I have done here, I have selected men. Now I am talking about women selection. So out of these 9, 2 cannot be selected, right? Why? Because let's say if I have selected M1 and M2 men, right? So that means I actually cannot select what? I cannot select W1 and W2 because that will be their vice will be playing with one another, right? So I cannot select W1 and W2. So I am left with only how many options now? 7. So that means you will do 7C2. So for women you have 7C2 options. So this should be your answer. So generally people say, sir, this is the answer, but this is wrong now. Let me show you how. So let's say we picked M1, M2 in the men counterpart, and let's say W3 and W7 for women, right? Okay, now I can say they are not the couples. So how a game can be played? So let's try and form a match. Match 1, right? So match 1 could be something of this pair M1, W3 versus M2, W7. This could be a one mixed match. Of the same players, another match can be made by, if I say M1, W7 versus M2, W3. So these two matches could be formed. Can you see? By the same configuration, by the same set of people, I can have two kind of matches available. So that means I will have to multiply this number by 2 also. This is the arrangement part. The final answer to this particular problem then becomes 9C2 into 7C2 into 2. This is the answer we were looking for. Got it? Clear? Okay, now let's move to the topic which says total number of ways of selection of distinct items. So now we are talking about total number of ways of selection, right? So it is divided in particular categories. First of all, we'll talk about the distinct elements, and then we'll also talk about the identical elements. So it says number of ways of selecting one or more item, that is at least one. So whenever you find something of the sort one or more, it is equivalent to saying at least one, right? These two things are same, at least one or more. From a group of n distinct items is, you have to remember this as a formula first of all. So add this to your formula list. So this is the formula that you people have to use. So it says if there are n distinct items, and remember this formula is for only distinct items. So if there are n distinct items, then the total number of selections, total number of ways of selection is nothing but 2 raised to power n minus 1. So now let us think of how we are getting this answer and what do we mean by total number of ways of selection. So selection की अगर हम बात करें, if we talk about the selection front, so selection could be that you picked nothing, 0 selection, there could be 1 selection, there could be 2, 3, 4, and you can also choose n out of n. So now let us go about how do we do this. So out of n elements you select 0, that could be done in NC0 ways. You select one element, that could be done in NC1. This could be done in NC2. Similarly, if I talk about this, NC4, and this could be done in NCn ways. So answer would be what? Which will add all of them. So if I add them, let's see what will become NC0, NC1 plus NC2 plus NC3, right, and NCn. And if you see this properly, this is a binomial expansion, sum of binomial coefficients. So what is the property of sum of binomial coefficient? That it becomes, yes, it is 2 raised to power n. So people who are not comfortable with the binomial, so just try and work around for this. Expand this binomially and put x equal to 1. This is just a hint that I have given to you people, but you should remember this particular formula. So there is a sum of coefficients, binomial coefficients we know is 2 raised to power n. If you see in this particular case, I have included NC0. So NC0 means the case of, NC0 is nothing but case of no selection. Case of no selection, that means you did not select anything out of the n items. So you do not want this because you are talking about at least one selection, right? So for at least one, you should take this to this side. So if I talk about this NC1, NC2 up till NCn, so this answer comes out to be 2 raised to power n minus 1 because NC0 is nothing but 1. So this is the particular answer we are talking about, and that has become as formula for us, right? This is the formula. The other way of thinking this problem is again very important. Why I am going with the derivation of this is because this is a very interesting way of how you think on the problems. Other way, so the B part, the other way of thinking this is, let's say, so there are n items, right? Let me write item 1 as A1, A2, A3, A4. So these are all the items that we are talking about. They are all distinct, right? And you want to find the number of ways in which they can be selected. So every item here has two ways. Either it could be selected or it could not be selected. Same here, two options, two options, two options, and this also has two options, selected, not selected, right? So if we go ahead with our dash problem, remember dash, basic dash problem. So so this is dash is number of options A1 has, number of options A2 has. So it has two options, it has two options, two options. So every dash will be filled by 2, and 2 will be multiplied how many times? N times. So it comes out to be 2 raised to power n. And then we will subtract 1 out of this. Why? Because there will be one sequence will be such, one sequence will be there in which all of them will be not selected, not selected, not selected, not selected, not selected. So we will have to subtract that one sequence because we want at least one selection should be there. So these are the two methods by which you can actually prove this formula, and this is, both of them are very important. You should actually know how we have solved them. Alright, let's apply this into a particular problem now. Problem now will become very easy. So the problem says you want to invite 5 of your friends to a party. Okay? And in how many ways can you invite at least one of them? So at least one of them. So there are 5 friends to be invited. 5 friends. So for example, 5 friends are there. You want to invite. It is not given that you will definitely invite all the 5. So now again, every friend has an option that he could be invited and he could be not be invited. Again, two options, two options, two options, two options. So it should be 2 raised to power 5, but you want at least one of them to be invited. So that means you will do -1 because there would be one sequence which will say not invited, not invited, not invited. Your answer is nothing but 31 is your particular answer to this problem. And this is how you can apply this concept in these kind of questions. Now let us take the other case, which is we want to find total number of cases in terms of identical objects. Now first of all, try and understand what do you mean by identical objects. So अभी तक जितना भी we have taken all our distinct objects. So now we are talking about identical objects. So what do you mean by identical objects? So that means you cannot differentiate, right? Differentiation is not possible. So differentiation is not possible among the objects. So this is the meaning of identical objects, or the reciprocal of distinct. So for example, if I say, if you people have seen the billiard table, so billiard table has all red balls, majorly red balls, right? So all of them are identical. You cannot identify sort of that red ball or this red ball because all of them sound same. So that is what is meant by identical. So now let us talk about how do you select when the items are same. So for example, again we'll go for selection first, right? Selection could be 0 selection, 1 selection, 2, 3, 4, and you can select all of them. So out of n identical items, if you want to select 0, in how many ways you can do so? Only one way. That means you didn't select anything. So that means there is only one way that you can select nothing is don't select, right? In how many ways can you select one item from a pool of n identical items, right? So now people generally here do a mistake that they write NC1 very quickly. So first of all, remember that whenever you are saying NC1, so for n here should be distinct. Obviously this formula is wrong here because here n is not distinct, it is identical. Surprisingly, here also the answer is 1. Answer does not change, answer is still 1. Why? Just imagine there are n identical red balls, right? When I say identical red balls, so that means you cannot write R1, R2, R3, something like this. You can only write this sort of thing when they are distinct. That is why you can say that is R1 ball, that is R2 ball. So now when all the balls are identical, that means you can just write R and so on, right? And if I tell you that you have to pick one ball out of it, whenever, so understand it that way, that you have a bag. So whenever, and there are n red balls in a bag which are all identical. So whenever you pick a ball, what you will report to me? You will say, sir, red ball. You put that back in the bag, again pick a ball. What do you will report to me? Sir, a red ball. So does your answer change? No, your answer does not change. So for that is why I am saying every time you will just say me, sir, the same red ball. I don't know which one. So 1. Similarly, if I talk about 2 red balls are to be taken from this bag, what you will report? Sir, 2. Every time you will say, sir, I think these are the 2 red balls which are same, right? So you will not be able to distinguish. So again, for 2, for 3, for 4, for n also, all the answers are 1. So if you see, total number of ways of selection in case of identical items becomes what? N. Again wrong. So if n would have been, if I have talked about at least one selection, if I talk about total selection, it will be n plus 1. And if I say at least 1, yes. Now if you tell me at least 1, then yes, the answer would be n, right? So the total number of ways in which a ball can be selected would be n. So here, minded, it is written wrong. It should not be. For 0 or more means n plus 1, at least 1. So 0 or more. This is the answer for 0 or more. And this is the answer for at least 1, right? Okay. Now this I have taken when there were only red balls in the bag, right? There could also be green balls. For example, now let's say there are p red balls, right? There are q blue balls, and there are green balls, right? So, and all these balls are given to be respectively identical, right? They are respectively identical. So in how many ways total selection could be done? So if they are different categories, so what we will do, we'll combine all the formulas. So for if there were p identical balls, the answer would have been what? P plus 1, right? If there were q identical balls, the answer would have been q plus 1. For r, it will be r plus 1. So this is the answer when they are asking total number of ways, right? And if they ask at least one, that means you have to at least select one. Just subtract 1 from the answer. This one will be when nothing is being selected, right? So p plus 1 actually includes your that answer where p will be included or not be included. Q plus 1 is also including the answer where q can be included, or that means blue ball can be included or not included. R plus 1 means that green ball may be included or not be included, right? And there would definitely be a one case which would say not included, not included, not included. That is the one sequence, and we have to subtract it, right? This is how you should remember this property. So let us apply this in a particular problem. The problem says that a bag contains 3 1 rupee coins. So 3 rupee 1, 4 50 paisa coin, right? Rupee 50, and 5 rupees 10 paisa coin, right? This is I can say. Okay. And now you people tell me that whether this is identical or not. All rupee 1 are identical because they have the same value. Whether they were printed in 2012, 2013, or let's say in 2016 or 2017, it doesn't matter because you will always tell them that they have the face value of rupees 1. So all rupee 1 are identical, all 50 paisa are identical, or 10 paisa are identical, right? So that means we can say there are 3 categories of identical items. This is 3 times repeated, this is getting 4, and they have 5 in the C category option. How many selections of money can be formed by taking at least one coin from the bag? So you will pick a coin from the bag. You are being asked in how many ways you can do so. As simple as that. And now you people know the answer. This is P, this is Q, this is R, and you have to select at least one coin from the bag. So the answer would be using this particular formula. Remember, we just did it. Very, very simple. So n minus 1 for at least 1. So this becomes what? 3 plus 1, 4 plus 1, right? 5 plus 1 minus 1. So the answer would be nothing but 4 into 5 into 6 minus 1, which is nothing. This gives you what? 120. 120 minus 1. So answer we were looking for is 119. So C is the answer. So this is how you have to grasp this particular problem. Okay, now if we were to take selection in terms of mixed items, so what do you mean by mixed items? So mixed items, if I have to tell you, so mixed item means P alike. They are P items which are of one kind. So for example, P red balls. Then they are Q alike, right? Q red balls, and R alike, right? Let's say R blue balls. And there are N distinct items also. So in a bag there are various things. Let's say P red balls. So for example, P red balls, right? Q blue balls, R white balls, and they are N distinct objects. So I don't know what it is. It might not be balls, but they are different items, right? You can say a pencil, for example, it's a pencil, it has a pen, right? A scale, whatever you want to say. There are various things in the bag, but they are N and which all are different. So in how many ways out of this particular bag now you can select items? So very simple again. For P identical item, what was the answer? P plus 1. For Q alike, Q plus 1. For R, R plus 1. For N distinct items, we just did 2 raised to power N, and minus 1 for at least one selection. So this answer is for at least one selection. Right? You got it? I think you people might have now got what I'm talking about. Now let us apply the concept of total selections of identical items in number of divisors of a particular number. Very important category of question. So for example, it is said that the number is 10800. You need to find, so these are not the options that I have given, these are 4 questions. A, B, C, D, and are the 4 questions. So n is 10800 and you need to find the number of divisors of n, right? So first thing that you have to do is do prime factorization. You need to do prime factorization of this particular number, right? Start from prime factorization, start doing it. Okay, so this will be the prime factorization of this particular number, 2 raised to power 4 into 3 cube into 5 square, right? So now if you see all 2's are same, let me also revise this concept for you people. So if I write 2 like this, or I like this, or let's say like this, what will you say? All these are 2's, right? That means all the 2's are identical, whatever in whatever fashion you people write, right? So I now have a question which says there is a number 2 which is getting repeated 4 times, right? There is a number 3 which is getting repeated 3 times, and there is a number 5 which is getting repeated 2 times. So how many total selections are possible for 2? You can select it 0 times, you can select it 1 time, you can select it 2 times, 3 and 4 times. Can you see if I say in how many ways you can select 3? You might find a factor or a divisor which will not have 3, so that means it has 3 raised to power 0, right? It has 1, 2, and it can have all the 3's. It could be 0, 1 and 2. Getting it or not? Right? So let me find a table for, right? So this is this kind of table. So 0 means that 2 is in the factor 0 times, 2 1, that means 2 raised to power 1, 2 raised to power 2, that means 2 raised to power 2 means 2 is getting in the factor 2 times, right? So this is what is meant. So now you want that your bag has these many options available. So how many total options here for 2? 5. How many total options here for B? 4. How many total options here for 5? So the net answer for your A part, that is how many total divisors are there, is 5 into 4 into 3. That is the answer we were looking for. That's it. So 60 is the particular answer. Amazing, right? So in fact, if you talk about, sir, how we can get a factor, so let me just explain it to you. So if I talk about divisor, 1 is a divisor of this number. How you will obtain 1? When 2 is raised to power 0 multiplied by 3 raised to power 0 into 5 raised to power 0. See this first row, right? The number itself will be divisor, right? How you will obtain this? When 2 is 4 times, when 3 is 3 times, and 5 is 2 times. Got it? Understood? And mind it, there is a special term that these two numbers are not counted as proper divisors, right? So if somebody had asked you find the number of proper divisors, what you will say? 60 minus 2. So that is 58 proper divisors or factors are there of this particular number, because 1 and the number itself are always the factor of any particular number. So we do not count them under proper factors or proper divisors. Got it? So this is how you solve the first part. Now moving to the second part, find the number of even divisors. Alright, so how do you find even divisors? Just think of it. There is a very important word here, that even. So what do you understand by even? Even must have a 2, right? Just think of it. Yes, so even must have a, so if it must have a 2, so then what values 2 can take now? Can 2 be 0? So if I say 2 0 here, so 2 0 means 2 raised to power 0, that means there is no 2. So I will start the table from 1, 2, 3 and 4. I will not have 2 raised to power 0, right? 2 will have to be included, so that means you cannot say that 2 is not selected. 2 ki power 0 means that 2 is not selected. What is there with any condition with 3? There is no problem with 3, right? No problem with 5. You select 5 or not, it is not my problem. So how many options here? 4. In 3 also you are getting 4 options. In 5 you are getting. So this is the answer we were looking for. The answer to this problem is 48. The number of even divisors in this particular number is 48. Obviously the odd would be if you subtract it from the total, right? That is 12 are the odd number of factors. Let's talk about the C part now. So C part now says find the number of divisors of the form 4n plus 2. So 4m plus 2 type. What you can say about 4m plus 2? So for 4m plus 2, let's say first of all, let's take 2 common. Right? Something of this sort. So what it means is 2 is even into, this is always be an odd number for sure. So this is even into odd, right? And for even also you should not write even, in fact you should write 2 into odd. This is the particular condition derived in this stuff, right? Can you draw again the table for me for this? How many values of 2, 3 and 5 you people can take? Just think of it. So you want 2 into an odd number, right? So how many values of 2 you people can take? I will say only 1, that is 2 raised to power 1. So 1 here means 2 raised to power 1. You cannot have 2 raised to power 0 because you will not get 2 here. You cannot have 2 raised to power 2 because you want it of the type 2 into odd number. So if I say I have included 2 raised to power 2, so that means what you people have done, you have put it 4 here, which is not possible. And what about 3? 3 is again not a problem. So you can have all the values of 0 bhi lega, 1 and 2, no problem. Why? If you say 3 raised to power 0, we know that this is 1, 5 raised to power 0, this is 1. What is the problem? 1 is an odd number, bhai. 1 is odd, that's not a problem. That serves our purpose. So how many options again are here? Let's count again. So for 2 there is only 1 option. For 3 there are 4 possible options. For 5 there are 3 possible options. So the answer to this problem is 12. It has 12 cases possible. And now let's take the last part, which is the D part. So D says that you need to find the number of divisors which are multiple of 15, right? So when we talk about number of multiples of 15, so tell me what do you mean by multiple of 15? How you will obtain multiple of 15? For a 15, at least 1, 3 and 5 should be there, right? Then only you will get 15, na? So there has to be 1, 3 and 1, 5. So how many options now? Let's talk about again in this particular table, right? How many options you can have? So is there any problem with 2? No problems. 2 can have any value. 0 be 2 raised to power 0. Whether that means 2 can be selected or not selected, that's not my problem. 2 is selected 1 time, 2 is selected 2 times, 3, not a problem. But yes, now you cannot have 3 raised to power 0 and you cannot have 5 raised to power 0. Why? Because you need at least 1, 3. So it should have one selection of 3. 2 is okay with me, not a problem. Same here, 5 should be selected at least 1 or twice, that's not a problem. So the answer to this problem then becomes, this is saying what? 2 has all the 5 options available, 3 has 3 options available, 5 has only 2 options available. So the answer to this particular problem then becomes, for this answer is 30. I hope you are clear with this particular kind of question. Very important problem. Re-revise it again and again because this is what is certainly will be asked in some or the other form in the paper. The other concept which is asked on selection from identical objects is sum of divisors. We just did the total number of divisors for this particular number 10800. So first step was to do prime factorization, which we did as and we obtained this particular step, right? So you are being asked now sum of all the divisors. So if I ask about number of divisors, so we just did how we find number of divisors is very simple, that is 4 plus 1 into 3 plus 1 into 2 plus 1. So this answer was 60. So if you are being asked, if you add all these, if you add all 60 divisors, what will you get, right? Okay, so this is being asked here. I'm not going to the proof of this, I'm just going to explain you how the formula works. Okay, so the formula is, so you have prime factors of 2, 3 and 5, right? So 2 has the minimum power 0, right? That means 2 can be selected one time, 2 can be 2 can be selected 0 times, 1 time, 2 times, 3 times, 4 times, right? That is the maximum thing that you can do with 2. Right? Similarly start with 3. 3 can be selected 0 times, 3 can be selected 1 time, 3 can be selected 2 times, and lastly 3 can be selected all the 3 times. Similarly for 5, 5 can be selected 0 times, 1 time, or 5 could be selected 2 times. That's it. This is your answer. So add all the powers of 2 multiplied with adding all the powers of 3 multiplied with adding all the powers of 5, and if you see individually all of them are GP. So just apply the formula for GP. So it has how many terms? 5 terms. First term being 1, 2 raised to power 0 is nothing but 1. So what you will say, 2 raised to power 5 minus 1 by 2 minus 1 into how many terms are there? Yes, 4. 3 raised to power 4 minus 1 by 3 minus 1 into 5 cube minus 1 by 5 minus 1, because common ratio is here 5. This is how you find this answer is nothing but what? Sum of all divisors, right? I'm not getting into the proof how I got to it. It is not relevant, and given the time frame that you people have, I will not advise you to go into the depth of this. But you should remember how we have found the sum of all divisors. Got it? Okay, now let us start circular permutation, which is another very important topic. So first of all, let's talk about the formula for circular permutation. So we know that for line arrangement, right? For line arrangement, so what do you mean by line arrangement? I'll just so line arrangement, for line arrangement, that means n people in a row. Line arrangement, whenever we use the word in row, right? So the answer for this was what? N factorial. So for n distinct objects, when n distinct objects are to be arranged in a circle, right? They are to be arranged in a circle, the answer becomes n minus 1 factorial, right? So this is how you have to remember. So for here it was n factorial, here it will become n minus 1 factorial. So let me show you with the help of an example that why we are doing n minus 1 factorial, right? So let's say there is a circle and I am trying to arrange 4 people in a circle, right? Let's say I seat them like this, A, B, C and D. Then I rotate them in a clockwise fashion. So this should become, this will be A here, right? This will become B and this will be C. Rotate them again, so this position will be held by, just do this activity. So these are the 4 particular positions that I can draw for the circle. Now in case of line arrangement, since 4 people are there, so in case of line arrangement there would have been 4 factorial answer, that is, you can say 24 arrangements would have been there in case of row. Now what will happen in case of a circle? So for a circle to become a line, what we can do is we supposedly cut it from here every time, right? You cut it from here. So if you cut it from here, this thread would look something like A, B, C, D, which is one arrangement in row. This would be start from here to go to end of the thread. This will become D, A, B, C, completely different arrangement from this. Now let's talk about this. This will become C, D, A, B, right? And this would what become? Yes, B, C, D, A. So these are the 4 different line arrangements which actually become one. They become one in case of, got it, in case of circular permutation. In case of circle they are all one. Why? Because anyway you see the left in circle, what you see, left and right, who is sitting to your left, who is sitting to your right. So always A has left and right as D and B. See to it in all the 4 diagrams. So that means all these 4 cases were reduced to 1, or in fact you can say your answer to this problem was reduced by 4. So what is 4 factorial by 4? That is nothing but 3 factorial. So if I analogically apply this, if there were n people in a row, your answer will get reduced by n. This becomes n minus 1 factorial. So this is how you actually derive the formula for circle. Let's apply this now in a particular problem. So the problem says, in how many ways 5 Indians and 4 Englishmen can be seated in a round table conference? And these are the 4 questions. So if there is no restriction, so how many people are there? There are 9 people. For 9 people to be arranged in a circle, the answer would become 8 factorial. So this is the answer for the first part. Very simple stuff. Let's talk about the second part. All 4 Englishmen sit together, right? So you want all the Englishmen to sit together. So we have done the case of questions where some people sit together. So what we'll do, we'll form a group out of them. micro view, remember in the previous lecture I did. So that means rather than saying 4 Englishmen, I would say this is 1 Englishman, right? 1 people. And there are 5 Indians. So that means in total there were 5 Indians. So in macro view, what I am seeing, 1 Indian plus this 1 Englishman. So there are total of 6 people to be arranged. 6 people to be arranged in circle, right? So how we can do that? Yes, we can do that very easily in how many ways? Tell me. 5 factorial ways. But this is not the answer. This was the answer for the macro view, जब आप दूर से देख रहे हैं. But what about this component? We have Englishmen which are seated common. So the answer to this particular problem then will become 5 factorial into 4 factorial, because the 4 Englishmen can be seated in 4 factorial ways. Mind you, some students here actually answer this particular answer, 5 factorial into 3 factorial. What they do, they try to arrange 4 Englishmen again in a circle. Never do this activity. So when you have answered this 5 factorial, that means you have drawn them on a circle, drawn a circle already, right? So the next answer of arrangement will never be in a circle, will never be a circle. You just remember it like this. Circle will be drawn only once. You cannot draw circle twice. So for all other arrangements, you will follow now line arrangement. If a circle has been drawn, you will now only follow line arrangement. You will not follow what I call as a circular arrangement. So 5 factorial has already taken into account your circular arrangement. The next would be 4 factorial. So this is the answer. Reject this answer. This is not the correct answer. Remember. Let's take the third component. It says all 4 Englishmen do not sit together. So now something of very different. Let's see how we apply it. So very interesting problem. It says that all 4 Englishmen do not sit together, right? So let us talk about that group on which there is no condition. So Indians do not have any condition. So first of all, let the Indians be seated in the circle, right? There are how many Indians? There are 5 Indians, right? So 5 Indians have been seated in the circle, and for a circular arrangement, 5 people can be seated as into 4 factorial ways. Got it? Clear? Now you want no 4 Englishmen to sit together. That means between every Englishman there should be an Indian. Accepted? So remember the dash problem that I did in yesterday lecture? How many dashes can be drawn? There are 5 positions, and if any of these 5 positions are taken by the Englishmen, they will always find an Indian to their left and right. Remember? So out of these, I can say there are 5 positions and there are 4 Englishmen. So out of 5, you have to select 4 first of all. Let's see. If I say Englishman here, Englishman 2, Englishman 3 here, and Englishman 4 here. So if you see any 2 Englishmen, there is always an Indian in between. Do not worry about, sir, these 2 Indians are sitting together. It is not given in the question. We wanted 2 Englishmen not to sit together, whereas it could be possible that Indians will sit together. And I told you yesterday also, if the numbers are not balanced, that is, one is greater than the other, obviously one group will have to sit together if this is the answer, if this is the case. And then they would also arrange them. So in how many ways the Englishmen will arrange? 3 factorial or 4 factorial? Remember, they will again arrange them in 4 factorial, not 3 factorial. We have already drawn the circle here. Keep this in mind. So this is the answer we are looking for in this particular problem. Let's take the fourth one. The fourth one says no 2 Englishmen sit together. Okay. Oh, okay. My mistake. First of all, the answer that we have just solved is actually, this was not the third one. It is the fourth one. When we say that no 2 Englishmen sit together. Now let us solve the third one, where they say that all 4 Englishmen do not sit together. This is what we have already solved. This is the component of first and second. So all 4 do not sit together. It is what we have already solved. Do not sit together, right? So what we can say when all 4 do not sit together is total cases, right, minus those cases when they sit together. And this is what we have actually solved in part 1 and part 2. So the answer is nothing but 8 factorial minus this particular answer, that is 5 factorial into 4 factorial. So this is the answer to this particular problem, right? Let's take another problem on circle permutation to understand it better. It says a round table conference is to be held between 20 delegates of 20 countries. So there are 20 people for me, right? Delegates or people are one and the same thing. So there are 20 people for me in the round table. So they are seated in round table. In how many ways they can be seated? If two particular delegates are always to sit together. So out of these 20, two always sit together, two sit together, right? Now we know this how to solve this. So for example, we will consider them 1. Consider them 1, right? So that means 18 were left, and since you have considered these two as 1, so total people are in the macro view, they are 19 people for me. For these 19 people, now you want to arrange them in circle. So for circular arrangement, we will say 19 people can be arranged in 18 factorial ways. Into now, if I go into this is the macro view, right? And if I go into the micro view, that I have these two people sitting together as a group. So what I can say? Yes, 2 factorial also. So you will multiply 2 factorial also. So this is your particular answer to this question. This is the answer, right? Let us just consider another case. There were 20 people and 3 people want to sit together. 3 sit together. What you people will do in this category, right? So 17 were left. These 3 sit together, that is 1. That means there are 18 in the macro view, right? 18 people in the macro view can be seated in 17 factorial in circle. And if I talk about the micro view, 3 people can be again arranged in 3 factorial ways. Minded, in the micro view, I will not use the circular permutation because I have already taken circular permutation here, right? Circular permutation is to be applied only once. I hope this point is clear. Okay, so next topic that we have to talk about is dearrangement. It means that if n items are arranged in a row, then the number of ways in which they can be rearranged, so no one of them occupies the place assigned to it. Let me simplify this with you, and let's say there are n envelopes. This is the category of questions which are asked, n envelopes, and there are n letters, right? So actually n letters which are addressed to their corresponding person should go to the corresponding envelope. So for example, in the envelope, let's say this is the envelope. You have already written to, let's say, Mr. A, and this letter over here, right, is also addressed to Mr. A. So that means this letter should go only to this envelope. Otherwise, if I say there is a letter which says to Mr. B, right, to Mr. B, and if this goes to this letter, then then we call this case as dearrangement. That means this has been dearranged. This case would have been case of arrangement, that it has gone into its proper place. But if Mr. B's letter goes into Mr. A envelope, or Mr. C goes to Mr. A, these things are called dearrangement. So if there are 5 letters and you want to dearrange them, so this is the formula that you people have to use. This is generalized for n things. So if I have to talk about that 5 letters are there and there are 5 envelopes and they are dearranged, right? So that means none of them got into the correct envelope. So the answer would be 5 factorial. Let's replace n by 5. 1 minus 1 factorial. So alternative plus minus. Plus 2 factorial minus 1 by 3 factorial minus plus 1 by 4 factorial, and we'll go till 5 factorial. That is how we solve this. So this is the answer of dearrangement. So you can say these are total cases of dearrangements, right? I hope this is clear. Let me apply this in a difficult problem. So see, it says a person writes letter to 6 friends and addresses the corresponding envelope. So that means he have written Mr. A, and on the envelope also he has written Mr. A. So the right letter should go to the right envelope. In how many ways can the letters be placed so that at least 2 of them are in the wrong envelope? So now what we did earlier was total dearrangement. So for total dearrangement was when everything went in the wrong place, right? Now they are asking very specific, at least 2, right? So for at least 2, what I can say, let's draw case 1, right? When 2 are dearranged. At least 2 means when 2 are dearranged, right? So for 2 dearranged, what you will do? There are total how many things? 6. So first of all, out of 6, you will choose 2 for which 2 has been dearranged. So 6e2 into formula for dearrangement, and I would say d2, right? So what does d2 represents here is d2 is 2 factorial 1 minus 1 factorial plus 1 by 2 factorial. Remember the formula for d. case 2 would be 3 dearrangements possible, right? For 3 dearrangements, what I'll say, first of all, out of any 6, 3 could be dearranged. So for any 3, you would say 6e3, and then you will use the formula d3. What will d3 here be? Yes, now you are getting it. 3 factorial minus 1 by 1 factorial, 1 by 2 factorial minus 1 by 3 factorial. Then case 3, getting hold of it? 4 dearrangements possible. This would be 6e4 into d4. Similarly, 6e5 into d5. And similarly 6e6 into d6. This is the case, this last case is the case of total dearrangement, which we did in the earlier question, apart from the earlier case 5. So this case 6 is actually your total dearrangement case out of these all 6. So if you add them up, adding them up will give you the answer. Adding them will give you the answer, right? So this is how you have to solve these kind of questions. The second part was all the letters are in the wrong envelope. So this is nothing but case 6, right? So this is how you apply the case of dearrangement. Now let us solve a very interesting concept, which is exponent of prime. Okay, and let's start doing with then help of an example or a question. It says find the exponent of 3 in 100 factorial. So first of all, what do you mean by exponent? Exponent is nothing but power, right? Exponent means power. So whatever we are going to study here, remember exponent of prime is the topic. So we can find only powers of prime number, right? Remember prime factorization for this. So we can only find powers of a prime number in a factorial. So rather than saying exponent of prime, I should say exponent of a prime in n factorial, right? So for example, if I take this the first problem, it says 100 factorial, right? So you want to find power of 3 in 100 factorial. This is the question. So how do you actually solve this? Now let's see. Very interesting stuff. So assume that n here is 100. What you will do is 100 by 3, and this bracket means GIF. This is GIF function, greatest integer function. Then do 100 by 3 square, right? Then do 100 by 3 cube. Goes on till you get a 0, right? 100 by 3 raised to power 4. And if you see, if I have to write the next one, it is futile. It is futile to write this also and the further steps also. Why? Because let's see, it is 100 by 3 will be 33 point something. So the GIF of it, that is the integer part of it, will be 33, right? This is 100 by 9. This will give you what? 11 is the answer. Only the integer part has to be taken, right? So for GIF, remember 11.99 is again equal to 11. It is not round off. It is not 12, believe me, right? So this is GIF, floor function. This is 100 by 27. 100 by 27 will have 3 as the quotient. 100 by 81, there is only 1. This will give you 0, and all the subsequent terms will give you 0. So there is no need of writing them. Just add them up. What value you will get? 48. So that means you will have 3 raised to power 48 in 100 factorial. So 3 will be there 48 times in 100 factorial. That is what is meant by this particular concept, and this is how you have to find answers in this. Let us apply this in the second problem. It says find the exponent of 15 in 100 factorial, right? So for 15, how you find 15? 15 is what? 15 is nothing but 3 into 5, right? So you already know what is the power of 3 in 100. So in 100 factorial, right, 3 is getting repeated 48 times. 5 is also being a prime. You can also find power of 5 in 100 factorial. Let's apply quickly in here also. So it will say 100 by 5 plus, yes, 100 by 5 square, which is 25. Do you think I have to solve it further? No need, because it will be now 5 cube, which is 125. This will give me 0. This gives you what? 20. This gives you 4. So that means it has the maximum power of 5 in this particular number, that is 100 factorial, is 24, right? 3 was there for 48 times, 5 was there for 24 times. So how many times 15 will be obtained? Think of it. 3 is getting 48 times, right? 5 is there with you for 24 times. So how many times 15 will be there? Yes, 24 times. Obviously there is a limit, right? So if 5 is limited with a lower value, so that means only that many 15s you will obtain. So 15, so that means you will have 15 raised to power 24 in 100 factorial. This is what is meant by this concept. Brilliant concept. In fact, you will find this concept used in various MBA exams also. Let's take another problem to understand exponent of a prime. It says find the number of zeros at the end of 100 factorial, right? So you need to count number of zeros. What is when do you get a zero at the end of a number? Yes, when you have a multiple of 10. So that means it is asking exponent of 10 in 100 factorial. So this is the question, and this is now you people can actually solve. So 10 is obtained by getting 2 into 5. You have already obtained that 5 in 100 factorial is nothing but 24 times. We just did in the previous question, right? What will be 2? So for 2, let's solve. So 2 will be 100 by 2. I'm just solving, though in fact it is not required. I'll tell you why. This is by 4. Similarly 100 by 8. Getting it? This is how you solve that. So for 2 it is the lengthiest calculation, 32, and this will be the last one, 64. After that you people will not require, because otherwise it will become 0. So this is 50, 25, 12, 6, 3. This will be 3 and this will be 1. So this is how you will calculate the powers of 2 here. So if you solve this, you will get answer as 97. So that means 5 is there for 24 times, right? And 2 will be there for 97 times. Obviously, how many times 10 will be obtained? Obviously the lower value, right? So 10 will be for 24 times. So that means how many zeros at the end? 24 zeros. So zeros at the end would be 24. This is the answer. In fact, whenever you find a question which is of, let's say, 15, so 15 is obtained by 3 into 5, right? You just need to solve for 5 only. No need to solve for 3, because obviously as you move on, the higher the prime number, lower the exponent, and that will define how many times the bigger number will come. So for example, if you were to ask for 21, right? So 21 is obtained for 3 into 7. So you need not calculate for 3, only calculate for 7. This is the condition that you people should keep in mind. Next concept that we have to do is sum of numbers formed by digits. So sum of the numbers formed by n non-zero digit is given by sum of the digits, right? Add the digits which are given. N is number of digits. N is here number of digits which are there with you, right? That is n minus 1 factorial and 10 raised to power n minus 1 upon 10 minus 1. I could tell you the proof of this, but I believe that we are running really very short of time for the proofs. I'll just skip that for the time, though I have kept a page to make sure that I did the proof, but let's skip it for the time being. So it says find the sum of all, let's correct this, this is not 5, this is 4, right? This is sum of all 4-digit numbers that can be formed using digits 2, 3, 4, 5. So using 2, 3, 4, 5, you will have how many digits? You will have 4 factorial numbers, right? You want the sum of all 16, oh sorry, not 16, all 24 numbers. This is the target, sum of all 24 numbers. So the formula says sum of digits, right, which is here 2 plus 3 plus 4 plus 5, right? Then it says into multiplied by n minus 1 factorial. So n minus 1 factorial, n is here. How many terms are there, letters are there or digits are there? 4. So it becomes 3 factorial, right? Into 10 raised to power n minus 1 by 10 minus 1. This is how you solve. So it is nothing but 10 raised to power 4 minus 1 by 9. This is the answer we are looking for. So if you just simply solve this particular part, you will get your answer. So this is 9, this is 12, and this is 14. So 14 into 6 into 10 raised to power 9 minus 1 by 9 is your answer to this particular problem, right? Clear? Let's apply this in a different question. So it says find the sum of all numbers greater than 10,000 found by using digits 0, 2, 4, 6, 8 with no digit being repeated, right? So the same, but the problem, see what is the problem here? So there are 5 digits in total, if I see here, right? 5 digits. You want to find numbers which are greater than 10,000, and obviously if you start from 2, you will have numbers which are greater than 10,000 because it's a 5-digit number that you will form. So if I directly start applying the formula here, the sum of all of them would be what? 0 plus 2 plus 4 plus 6 plus 8 into 4 factorial into 10 raised to power 5 minus 1 by 9. This would be the answer. But there is a problem here. What is the problem? Can you tell? Yes, some of you have started thinking on it. Problem is we have taken 0 also. So for 0, there would be some numbers where 0 will come in the beginning. 0 will come in the beginning, right? And if 0 comes in the beginning, then this implies it will be a 4-digit number, right? It will be a 4-digit number. So this sum actually has these numbers also which are 4-digit because 0 you have included. So this answer contains your answers which are numbers which are less than 10,000 also. They are also being added into this sum. So you want to remove them. So what we will do here, so we want to subtract those cases, right? Now you understand, we want to subtract those cases. So just find some of these cases. So some of these cases, right, which we want to subtract would be 4-digit numbers. So they are what? 4-digit numbers. So 4-digit numbers will be formed using 2, 4, 6, 8. So what will be their sum? So their sum would be add them 2 plus 4 plus 6 plus 8 into, yes, now the value of n is not 5, it is 4, and this will become 10 raised to power 4 minus 1 by 9. And you want to subtract these, so the answer to this particular problem will be equal to, so just add them up, what this will become? 10, 20, right? 10 and 20. 20 I can take common. 4 factorial into 10 raised to power 5 minus 1 by 9 minus 3 factorial into 10 raised to power 4 minus 1 by 9. So this is the answer we are looking for. And this is how you solve sum when 0 can be in the first position. Apply the formula, subtract those cases which have been added extra to it. Another theory which though is not in the syllabus of JEE Mains, so completely I can say this is not in JEE Mains for sure, right? But still I'm doing it because in bit set you might get these kind of problems. So it says number of ways to divide n identical. So this formula is first of all for n identical objects and into R groups such that each group gets 0 or more. So the answer is, you have to remember this, n plus r minus 1 c r minus 1. This is when it is 0 or more. That means each here some groups can be empty. Groups can be empty. That's not a problem, right? They could be empty also. When you say that groups cannot be empty, that means each should have at least one. They should not be empty. Then the answer will become n minus 1 c r minus 1. Just remember this. This is just a formula. I'll just show you how you apply this in the problem so you will get comfortable. Okay. Mind it that these formulas are valid when you are dividing n identical items, not distinct items. Now let's see the question. It says find the number of ways in which 30 mangoes can be distributed among 5 people. So all the mangoes are identical. So first of all, just understand that mangoes are identical. No need to, be given this in the exam. Mangoes are identical. So n is equal to 30, right? And how many people has to be given? 5. Any other condition that given to you? So it could be that all the 30 mangoes are given to person 1 only. This is true, na? Right? There are 5 people. So it is not sure. It is not given that how many is the minimum value that should be given to each one of them. So I can give all the 30 to person 1 also. So the answer that you are going to use is which one? Just see to this. The first one or the second one? Second one is for at least 1 to each item or each group. No, it is not given here. So we'll use what? Yes. So the formula that we are going to use is n plus r minus 1 c r minus 1. So how do we apply this? Is 30 plus 5 minus 1 c, yes, 5 minus 1, this is 30 c4. This is the answer we are looking for, and this is how you solve these kind of questions. Let's do more of this, right? This is something very beautiful, and they are asked in some various forms. So for example, this is the category of questions which are asked. Find the total number of non-negative integral solutions. So what do you mean by non-negative? First of all, non-negative means 0, 1, 2, 3. This is the meaning of non-negative, right? So that means whole numbers we are talking about. So never start non-negative from 1. 0 is a non-negative number, right? So we'll start from 0. So you want values of x1, x2, x3 and x4 which belong to your whole numbers, right? Or let's say I write here which belong to whole numbers, and also they satisfy that their sum is nothing but 100, right? What is the minimum value that x1 can take? Min of x1 is 0. That means you are getting it now. Yes, you people are getting it, I hope. So it is actually equivalent to saying that 100 is what, when you get 100 is something when 1 is written 100 times and all ones are identical. 1 are identical. So that means how many identical items are there with you? There are 100 identical items. Then only you will get 100. So for this 100 items are to be divided among how many people? Divided among 4 boxes or 4 groups, right? Groups are x1, x2, x3 and your x4. You need to divide them in these 4 groups. Got it? Such that each group can get 0 or more. Here is the condition. What you will use again? N plus r minus 1, c r minus 1. That's it. Can you see this simple this problem was? It looks like a very intimidating problem at the first, but this is nothing a very simple problem. So this actually is 103 C3. So this is the answer we were looking for. Over. And if I had to change a simple, very simple stuff in this question, if I say find positive integral solutions, positive integral. So what the answer would be then? For positive integral, the value of x1, x2, x3, x4 will now belong to natural number. Natural numbers start from, yes, they start from 1, right? So that means now the group cannot be empty, because at least one item should be there. So if group cannot be empty, what the formula would be? N minus 1 C R minus 1. So the answer to this problem will then become 99 C3. Then this would be the answer. I hope this is getting clear to you. So now again the same problem, though we call them, if you want to get hold of what is this we are solving, this is called integral equation method, right? So we are doing just basic of integral equation method, though it is much more than this. So it says x plus y plus z plus w is equal to 29, right? And it is also given that x is greater than 1, y is greater than 2, z is greater than 3 and w is greater than equal to 0, right? Now we want to divide 29 into 4 groups such that this is the condition which is given to you. But the conditions are very varied. It is not that each group should be empty or more. What you should do is try and do something of this sort for every group. What do you mean by this is W group can take 0 or more. This is the meaning of this particular statement. And we want each group to have the same category. So what we will do, so let's see. So we'll replace x by capital X plus 1, right? So this becomes capital X is greater than 0. Similarly, capital Y plus 2. We are doing this just to form 0. Capital Z plus 3 greater than 0. This gives you capital Z is 0. And if you do the substitution here, it becomes C, this. Right? And for W, we do not require anything. Right? So now this question simplifies to this particular concept. Right? Where we have to subtract 6. So either you solve this or you solve this. Does not matter. So now the question is 23 into 4 groups, right, where each can get 0 or more, where each can take 0 or more. Got it? 0 or more. This is what is meant by it. Because now if you see the condition here, 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 and w is already greater than 0, now we know the answer. The answer is n plus r minus 1 c r minus 1. This is how we are going to use. So the answer becomes 23 plus 4 minus 1 c 4 minus 1. So this becomes what? 26 c3. This is the answer. I hope this is clear now. Okay, let's take a very interesting problem to understand the basic of permutation combination. I'll read out the question for you. So the question says, find the number of ways in which an ant at 0, 0 in this. So ant has to start from here, right? You can take ant, or you can just imagine yourself. It's a maze problem, right? We call this as a maze problem, right? Or in fact, if you are going to do computer science, we are going to call it the shortest distance problem also. Shortest distance problem, very, very important, right? In fact, you will be required to code this shortest distance problem, right? Let's understand first of all. So you are going to start from O in XY plane, and you want to reach this particular point B over here, right? You want to reach B, 4, 4. Traveling along the shortest path if this intersection path is closed off. So first of all, what do you mean by the shortest path, right? So understand that first of all. So what is the shortest path? So you are here at 0, 0, right? You want to go to 4, 4. So that means if I divide this chart into your east direction and your north direction, so that means to for 4, 4, that means how many steps in north? Steps in north. How many steps in north are required? 4. And steps in east should be 4, right? But it varies that how you reach 4. So for example, you can start from here also. See, I will just highlight 1 or 2. So this is one of the shortest stuff that you people can think of. The other would be something of this, that you travel from here and then you go here. Then it could be you travel here, then you go here, and then it could be when you travel here, you go here, then you go here, and then you go here. So these are all the different possibilities. But if I talk about the shortest, this is the shortest, right? And if I talk about how you find the, in how many ways you can do so, answer is very simple. See, how many total steps are there? 8 factorial, out of which 4 are of one kind, that is 4 in north and 4 are in east. So this is the total number of ways, right? So this is the total number of ways in which the shortest distance can be traveled. But now we have another kind of problem. So what is the problem? That we cannot go by this particular path, that is 3, 1. So we need to actually remove all those paths which have been through this. So we want to remove all shortest paths, right, which go from 3, 1. You want to remove them, right, or not? So how do we do so? So let's start calculating in a reverse way. So for if you want to go from 0 to 3, 1, and how many ways you can go? You want to go from 0, 0 to, let's say you want to go from this to this. Tell me in how many ways you can do so. You can do so, let's say I'll name this from A, this let's say is B, this is A dash, right? C and this. Okay. So this could be one way is to this particular way, 1. The other way would be go here and then go here and then go here, 2nd. Third would be go here, then go here and then go here, 3rd. 4th would be go here and then go here. How many? Yes, so there are 4 paths to reach here, right? And then from 3, 1, you want to reach which point? 4, 4. How many ways you can do so? Again calculate. So if you want to calculate, let's see, I can go from directly from here to here and then here, or I could go from here first, then here and then here. I could go from here, here and then to this point, and I can start in this direction and then directly go over here, right? So these are the, again, how many cases? 4, right? Got it? So in how many total ways are there? Answer is not 8. Don't add them. Why? Because just understand the fundamental rule of counting. So you are going from O to A and A to B, and your target is to go from O to B. And this has 4 ways and this has 4 ways. So total number of ways of reaching from O to B through A will be 4 into 4, that is 16. So 16 shortest distances are there which will go from A. Calculate this. What is this quantity? So if you calculate, the answer to this will come out to be 70. So what is our answer then? Our answer to this required problem is nothing but 70 minus these 16 cases, which is 54. So 54 cases are there where you will have to move the least, that is only 8 steps, and you will not also require to pass from 3, 1. Very interesting problems, you see. So this looks like a very, it looks like a puzzle, but this is how PNC is being used in puzzles. I could have taken much more problems, though I think I would upload 1 or 2 more problems maybe later, which are very interesting. And let's hope that you people are able to understand these kind of questions. Alright, so we come to the end of this particular chapter as well. And again, this is a very interesting chapter. In fact, I would have loved to take some more problems, but believe me, they are of no use. Right, so the first class, in fact, that is the yesterday class, was the most crucial class for this chapter from the point of view of JEE Mains. Right, in fact, I have taken various different topics, and the last topic, that is the, the integral equation method. It is not at all required. It is just that you can build up some confidence that you have done something extra apart from the syllabus. That is the reason that I have taken it. So don't worry about it. There are n numerous problems that you can still take on PNC, and believe me, it's very interesting. So, but at this point, you have to save your time. See to it that you are not doing too much and wasting a lot of hours doing this particular chapter as well. Right? The weightage, if you see about the weightage, a single question is going to be asked, and that too on a very easy level, not on a tough level. Right? So don't focus too much on it. I'll mail the worksheet. Again, it will be a basic worksheet. Don't worry, just solve it. Solve the NCERT example along with it, and you will be done with it. Alright, see you tomorrow with a new chapter, functions again. And I just hope that you are able to get hold of PNC. Okay, good night.